Hello. We're going live. We're trying a little bit of a different setup this time. So I'll be starting a manual recording in the middle, so we have less of the lead up and the trail off here. And also maybe save on some bits. Hopefully the connection's a little bit better for this stream here. Okay. As stated in the last video, I'm gonna go over here, and I didn't have time to do this off stream, so I'm just gonna do some of this real quick. I'll give people a few minutes to jump on so I can see if before we get started too far in here. Stream status, good connection. Okay. A little bit of fan audio. Yeah, cycles between. Okay, here, 1000. Okay. Alright. So we'll be doing that a little bit differently. Go ahead and turn these off. Look at the document for a little bit. And I'll probably do that code for a little while while we're waiting. And I think I can see chat through that, so I'll just work a little bit through there while this is running. So today starts at 10 and goes a little later. I want to check out the code. So code here, I'm just going to copy and do some cleanup stuff like I said I would yesterday. Making sure not to change any of the order on any of this. So we'll have this next one be idle. So we have stun, idle, stun. The next one is grind. Next one is drift. Next one is dash. And then last one is accelerate. So then once we get accelerate, then we start with, looks like this one. So then if is stun, yeah. Then is idle. Then we go down here and do the next one for grinds. GRIN is grinds. Next to this, and then on to the next one. which is tab to complete, not idle. We need isDrift. 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 And then dash. isDash. isDash, and then accelerate. V is accelerate. Is accelerate. Is accelerate. This last stun isn't necessary. Okay, and then we'll go into stun. Still some more cleanup. We'll do stun. We'll look for some state changes. What do we want here? We want acceleration, rate movement, race movement, move states, race movement, race state. It's going to be under accessories. We're just going to change in idle. Okay. So if you public override is, and we're idle, is idle. Oh. Is idle. We want to override that to get return. And we want to return true. And remove the semicolon. Actually, what I'm going to do is just copy this line. And we're going to go to bottom of grind and just do it this way. We're just going to change the name here. It's grind. Then we're going to go to this next one. Is grind. Is grind. What did I do here? This one is drift. Is drift, and then we go to this one, which will be is dash. That didn't rename. Yeah, it did. This will be is dash. Let's check my thing. Yep, still going. Okay. Is dash. So is dash. Last one is accelerate. ACCELERATE. Is accelerate. Okay, so we save all up. And once that finishes, I have one more thing to do before we get started, and that is to go in and just have this move context open, get to the change states. Okay. Move that into there, but then we did the same thing here, so we need to get rid of that. and just block comment this for now. Okay. And with that, we're 10 minutes in, so I think we'll get started on the progress for today. So we'll go look at the stream. No messages yet. Discovered. Okay. So with that, we'll start a recording, and we'll start just doing a recap quickly. Alright, hello scripters and kitties. We're starting finishing on the basic movement and our state machine. So in the last video we went over starting the state machine and we ran out of time. So we have our race remove context, a couple things that changed since last time as I look at change state. You'll notice in the other video I accidentally put it in here, so we just moved the current RMS up to here, that little operation, and I just blocked comment out void change last state. And then in further down we have the methods that change, so we hit stun and we do this operation. I just duplicated that for each state so that that would run for all of this, so that we can call this from our input manager rather than from our trying to put this and the input together. So it'll just separate things out a little bit better, make them easier to alter, which we'll actually get to look at today. Probably doing the acceleration type script, which will be in our accelerate underscore ms. So if we save everything up, we'll continue to move on towards idle and look at some of these. So like I did yesterday, we have the isStun boolean here, and I just did that for each one in its respective boolean, so that we know which state we're in specifically. You can just copy and paste one line and then change the variable name, which is what I did. It goes a lot faster. We can probably finally close this new mono behavior that we'll likely delete anyway. And then we'll begin work on actually making our input type class. But before we do that, we need to actually do one more thing. So if you remember the update and the other methods we took out, we have to put one of those back in. So on awake only runs on awake, and if you're not in the scene when you use awake, then it won't run. So what I like to do is either put that in enable, which is where I like to put it. So let's open up some lines here in methods in our race remove context. And what we're going to do is we just need our onEnable method. enab onEnable, and it'll autocomplete to a private void onEnable. These ones I usually use as private unless I really want to inherit a specific type of behavior for onEnable, specific type of base other than this. So you could use protected. Protected usually works for most of the Unity ones. So we have protected, and could do public as well. That's not great to have, because then somebody else might be able to call your onEnable, and you don't really want onEnable running unless it is enabling. So we'll just leave it private for right now, we can always change it later. So we'll leave it that way. And the next thing we want to do is on enable, we actually want to set up our states. So you can see here that these are basic C# classes, so these can just be instantiated by themselves. But we get to here and we can't necessarily do that for these guys because these rely on having one of these as a state. So you just kind of go down here and we need to set current RMS equal to what we want it to be on, say, start. So current RMS is going to need to be equal to a not get component. Autocomplete's not always great. We want idle, right? So idle MS. That just means that one that we created up there is now set to our current. Since we're doing that, we also never want any null references. So just to make sure last RMS points to something that is it has a value like these up here, we're just going to set it equal to the same. So we'll do current RMS. Current RMS is being equal to the idle MS, and that just ensures that we do in fact have both of them with assigned values, so that we can reference them correctly later. So if we look at that, that should all be good. So this starts on enable, starts as an idle, and then we change states. One more thing I'll probably do in here is I'll need a, because this is the movement based context, so this is the move context, so it's also going to have a update, and we just kind of want to figure out where we put the update. So do we put it in fixed update or do we put it in update? So update's going to be every processing frame. Fixed update's going to be every set amount of time. I believe it's like 30 frames by default. No, what is it? You can't move faster than 30 units, but you can have, it's like 50 by default. 50 every 50 frames. Yeah. Or has 50. It has 50 frames per second. I forget the exact amount of frames, but key being it runs lower, less often, and it runs all the physics information, which makes it a little bit bloated. So unless we're doing something with physics, we don't necessarily want to use fixed update. It'll make the application actually run slower, even though it's running less often. So, but we're going to use the physics-based movement type of style, so we want to use fixed update. Fixed update. And some people might argue that you'd put it in the state, so the state would have this fixed update. I just tend to run into problems with the rigid body access then. So if I just go here and like, so let's minimize all of this so that we don't have to look at it anymore. Let's open up a new region. So we have a new region, and what do I want to describe that region as? It is to, we're going to call this our movement variables. So this is MENT, movement variables, BLES, variables. Then we're just going to close that region. And when we close that region, now that region's closed, and we can put some stuff in here. And basically this is going to be a protected class name would be capital in this case, RIG rigid body, and convention for this is usually RB. Just because that's the generic shorthand most Unity developers use, I use it as well, just so everybody knows what we're looking at. You can name it anything you want, of course, but that works better. Rigid body variable, and this is going to be on this rigid body is going to be on the same level. We'll show you that in the inspector when we switch back over to Unity, but we'll look at this right now, and we'll go down to our on enable, and we'll also want to get this here. So let's leave a comment for this. Say this is for set up states. And then this is for set up object reference. And what we'll be doing here is setting up everything we need to access for the from the Unity scene, so that we have like our things we own here happening, and we have the things outside of here happening here. Things we need to access outside of this object. So RB is going to be equal to should be just get component rigid body, and that just means we're going to go out onto the object at this level and look for a rigid body on the object that this mono behavior is on. And then one extra thing I'm going to do, if I can remember the syntax, require component, and what was the syntax for that? Now we can get it. Require component 3 overloads. So it requires component, I think it's of type might have to look that up. Anyway, you can use, if you look up the required component, you can set it to require certain components so that your object can't build without it. So let's just comment that back out, and I'll look that up in a minute. Just do it by hand for right now. And then in idle, or let's actually go to accelerate. So if we go to accelerate, we can see everything we have here, but there's no movement. There's no move method anywhere in the script we made so far. So let's go back to our base class, because every class for racer move state, every racer move state is going to need a move method, even if it doesn't do anything. So we're just going to go into the methods, and we're going to maybe we'll make a region. And this region is going to be to handle movement and actions. So maybe type states, actions, and then we'll end the region. And we'll have a protected, not true, we'll need a public move, oh, no parentheses. and this won't return anything, so we go void. So we have a public move. That method will take an argument of rigid body, maybe. Rigid body because it needs a reference to do the thing. We could also just do a move context. So move context could pass it in whenever it calls a method. Just pass itself in. So let's do that actually. Show you some more ways that you can thread things through. Let's get our trace remove context as ARMC, and then we'll take our ARMC and we'll get the access to a, what would it be? Be a rigid body. So R, we'll do capital RB, and we'll do line end, and we'll just go make our in-race remove context. We'll move back down to our accessors because we want it to have a public get but not a set. We want only this script to do that, so let's go ahead and also comment again. So here in our accessors we want access to states. Access to states, and then here we want access to the game object components. Access to the game object components. And with access to game object components, the only one we're really working with right now is public. We want the RB, which is of type rigid body. So it's a public rigid body, and it's RB get return lowercase rb. And then with this, we can access it in a move state. And the reason it's red is because we're not doing anything with it. So we need to, we're just going to do a really basic one to make sure everything works. Add force, which is a rigid body function. So rigid body will handle all the physics and gravity on a particular object, or allow gravity to apply to it, and also force to apply to it. So we use add force. We're adding force to the rigid body that is of vector 3 and a force mode. So what's the direction we want? We're just going to add it in straight forward. So let's access A, R, and C. This is just for testing purposes. Dot transform dot forward. So we're basically setting it to go forward in a normalized amount of force. And this is not enough force to actually move a object of one mass, so we need to multiply that by, say, 10 so that we can see it happen. And then the second parameter is we need to do comma and force mode. Force mode is the type of force you want to add to it. You have a choice between dot impulse, which happens once and not again. So this would be a singular force happening every fixed update, which isn't the best idea. It tends to be a harder push, and it also, if you have it running multiple times, like every fixed update like we have it here, it's gonna push way too hard and way too fast. So we actually need force mode dot force, which applies as a constant force. Gives a little bit more of a gentle feel to it if you watch it in the editor, a little more constant. So with this, we should be able to go back to our remove context. And in our changed state, we just need to change this a little bit, not change state. In our on enable, we have idle. So we're going to test using accelerate just to make sure that this will, we have move defined in brace remove state, so it doesn't matter which state we're starting with. So we can leave it idle, get component rigid body, fixed update, and this will also tell us if we have a state where no force is supposed to be applied, that we didn't overwrite it and correct what our method is, if we just have a method that clearly looks wrong. So we need to just put move in here, so it's going to be, to call move, we just do current RMS dot move, and with move we pass in a parameter of this, which is passing in the context that this particular object is. And following that, we follow back to move, and we should move forward according to this game object. With that, let's actually take a look, and I want to try and flip over to the Unity display. So once all that is saved up, we want to look at our Unity display and our display of this object. So we have our player container, and let's flip to inspector. Now this player container doesn't have anything on it. This is just something I use to contain all the objects that a player needs, such as the body. So everything under here would be what the player is, like the physical player that you're looking at. And other objects in here might include a create empty. Let's just call this UI. If you have like a start menu or something that would be specific to a player or an object, I might put that in here. Let's also create empty, and there would be some sort of camera, and we'll cover why the camera is out here and not under the body, even though it follows the body. Just kind of this whole setup, the reason why we do that and why we nest them in this way. It's something I've altered a little bit from when I learned some things from Game Dev TV's course on Udemy, but we're going to use this for right now. So we look at player body. This is about where I'd want to put this player bod is about where I want to put my rigid body, because all of these are parts that would have colliders on them, or could have colliders on them. And what I want to do with that is I want my rigid body above all my colliders, because colliders go up to the nearest rigid body to register collision. So if I want collision information, I want it to be above all of my collision colliders, so that it's the only one that receives this information. Rigid body, I'm just gonna freeze all rotations. I don't like to leave my rotation open on a rigid body. I like to apply force with the transform. Uh, and you'll kind of see how I do that and why I don't want it moving. Next thing, let's make sure we have some colliders on our wheels at least. So not that one, not that one. Okay. There's two options for this. We can use wheel colliders or sphere colliders. I'm going to use a sphere collider just because I don't use wheel colliders all that much, and they have a lot of physics stuff that they can do that I don't necessarily want to use. So we're going to go sphere. Also, sphere collider is the most performant of all the Unity colliders. So if you're not using any of those extra physics functions, you might as well just use a basic one. And let's go ahead and view this head on. So this sphere collider pretty much mapped one-to-one with the size of the wheel and the center of the wheel. So if we look dead on it, I want to look at, so center's fine, center's perfect actually, absolutely perfect, but I don't want the radius to be quite, let's see if we can play with this a little bit. Oh no. Yeah, because it's a sphere. The only downside of having a sphere like this is that you can't edit the width because it's simply a radius. So let's actually remove the sphere collider. If we were thinking this through a bit more, I would probably put a empty object under that. And where's the other wheel? Other wheel's here. Yeah, so let's just go get empty objects under those. And we'll call this, what is that, left wheel? O underscore WHELE wheel underscore COL left wheel collider, and we'll go here in the right wheel collider. And staying with the same R underscore WH wheel underscore COL IDER. And we have right wheel collider. Reason I'm putting it on these objects, so if we add the sphere collider, then we can bump our radius up. Why is it so small? What's 9? Okay, 9's better. Yeah, it was like 9.4 or something, so let's do 9.5-ish. Yeah, that makes a pretty good hit. We'll alter that if we need to. So then let's go to the other one and do the same. Add component. Sphere collider at 9.5. And what do we want to do with that? So let's go ahead and look at our scale now. So you can lock and unlock the scale. I'm going to leave them unlocked for right now because I'm only going to change one at a time. So let's do 0.5 on this. What does that do? Well, that's interesting. I thought that this would change the wheel collider. Looks like that doesn't actually work, so we'd have to use them. This isn't going to look correct. It's going to work, but it won't look right. Okay, so sphere collider is a no. Let's add a box collider. So left wheel, add component, box collider. Reason I wanted to use this 9, 9, 9. So it's probably 18. Yeah, there we go. Size 18, 18, 18. Why is it? Okay. So let's try the Y, do a 20. Maybe the wheel's not perfectly round, or maybe the box collider is just different than I think it is. 18x2. You can type some simple calculations into these Unity fields and it'll change them for you automatically based on what the expression is. So this is looking fine. It's looking fine-ish. So that's our size, 18, 36, 18. I want to try one more thing. Create a 3D object that is a sphere. I want to affect his scale on one of these. It's probably the Z. That's not. And the collider just zooms to the biggest axis, which tells me what I wanted to know anyway. So that's not going to work. So we're going to use a box collider, which seems really weird when we're considering that it's going on a wheel. But there is a... It's not going to make that much of a difference in terms of how the wheel behaves. At least at currents. And we might actually swap this out to a wheel collider later. I just wanted to check. I just wanted to use this because this one's a little more tested and a little more reliable for new people in my experience. So we're going to go ahead and copy the component. We're going to go to our right wheel collider. We're going to remove this component. And if you hover over the transform and right click, you can think of the transform as like the base of the game object, since every game object must have one. We're going to go ahead and paste the component as new. So when you go to it, you can hover over the box collider that we first made, right click, and then copy component, and hover over transform of the new one we just we made, or the other one and just paste component as new. And it's not looking like what we saw on the other side. Which makes me wonder if these guys don't have a massively different scale. Which they don't. So why is the box collider on one not the same as the one on the other? Because only the position information is different. Oh well. We'll put this at 18. That should even it out to where it's supposed to be. We can always make it so that there's like a little sphere at the bottom to deter drag, and put a box collider up here so nothing's box colliding with it. There's a whole bunch of solutions, but we're just going to use this one for right now. I actually don't want it that wide. Can we bring it down to maybe 9, half that? Yeah. So let's bring this down to so weird. Anyway, that being weird aside, we can keep moving forward. We'll be looking at a different kind of thing here. Okay. Once this is all set up, we'll move into the next part, which is just testing in this move control context that we made. So player container, we want player body. We want to add component, and we want to add the component we just made, which is the move context. So it's racer move context. And it's enter key to select it. And so we have a script. Currently there's no parameters because all it's doing is getting the rigid body that's on here and creating those states. So I just need a decent view of this object. And it should start, drop, and go off the edge. Okay, so why doesn't it go off the edge? Or is it going off the edge? First one, let's try changing the speed. So if we go to scripts, we go to racer move states, we go to move states, and we go to move context. Or we can just switch over into our other tab, we go to code. So on enable, we set this up, we got the component, we got component of rigid body type, we have that shareable with the other one, rigid body RB, get return this little rigid body. And then we have the racer move state. The racer move state has move, which takes into context, looks for the context by 10. Let's try 100. Just to be sure, maybe 10 isn't enough. I usually use like 50 and stuff for a lot of mine. So we'll see if maybe 100 just makes it work. Come on, give me my mouse. There we go. Turn the code screen off, run a play again. And off it goes into the distance. So our acceleration's working. Next thing I would probably do is, since our move speed's a little bit more delicate than we thought it was, I might go ahead and do something like some kind of speed adjustment. Because we want this to be able to be changed, but we can't do it in the inspector, right? Because this is a normal C# class. And putting stuff in here is just going to make it kind of like boggy. We want to keep this really light, right? So how do we do that? We don't want a bunch of fields on this script that have to get passed in through to the state, right? That doesn't make any sense. So what I actually do is I make a parameter type thing. I'll show my code here. I actually end up making a parameter type thing that you can enter and edit using scriptable objects. So let's go ahead and show you what one of those looks like. I'll switch back to Unity real quick. And then we go race movements, scripts. I actually usually make a folder for the SCOs. So you have scriptable, scriptable objects, which I actually just abbreviate, maybe like SCO, and this one's specifically for parameters, so P params, and then I'll actually have another folder in here for SCO specifically, and I'll have another folder for params. Because I'm not editing both at once usually, it's one or the other. I'm either scripting an SCO or I'm creating instances and params. So let's go ahead and create inside SCO. Let's do create. So right click create the C# script. And we're going to call this a this is just going to be, should we call it Excel SCO? So accelerate underscore ms underscore SCO. Might be a bit more than we need to, bit more words than we necessarily need, but we can always rename it later if we find a better one that's more concise. And then I'll share mine. Like, I've already thought about it, and I actually don't like the MS's in there, so I'm just going to rename it without MS. Accelerate SCO. Then we're going to Control S. Is my mouse working? Yes. Okay. And then I'll still get rid of this update start, all that junk. Go up here. And what's today being 27/24, 7/27/24. And we're looking to accelerate mono behavior, all of this stuff. Accelerate SEO. So what's in here? Basically, my params are going to be like movement speed, and I might even break this down more. Would it be? So if I want to break it down more, maybe I should rename it again. I would call it Move State SEO. Move State SEO. Why Move State SEO? Well, I don't really need one for SEO for every individual class. I just need one that I can create for multiple classes. For example, they're all going to have a move speed, so let's do everything in protected for right now. But we do label our vars. Vars. We're not going to have any methods right now. We might have some. We'll definitely have some accessors. Definitely have some accessors. Do some more vars. And we're going to want a protected. So protected acceleration. What's a protected acceleration? That's fine, right? Shouldn't be capital. Acceleration, that's not a spelling line, that's a error line. Public acceleration of what type? It is going to be a float. Unity does not like doubles. It almost always uses floats. You can use decimal and floats in your code. It's just not a good idea to use it if Unity is going to access it at any point. Meaning, if your C# classes all use decimal and then you convert it whenever a Unity kind of object is going to ask for a number, it's fine, but don't put it in like a mono behavior script or anything. At least it was that way 2019. So we have acceleration as a float that's going to be equal to nothing. Let's give it a base of like 100 just so we can see that we do need to change it. Or maybe 100's fine. We'll find out. One thing we can do above this is we can make this since it is protected and we do want to change it in the inspector, we can make it a serialized field. People might have seen this is done with mono behavior a lot, and you can still do it on a scriptable object. It works exactly the same, except you do it in the inspector, like you would a prefab. So we'll go ahead and we'll write, so serialized field, protected acceleration, float. Okay, so what we can do here also is we can give serialized field, and then we can also give it a range. So we can do range, and range is another thing in Unity where you can set a specific range where it'll be usable. So if you want to keep your designers from entering numbers like negative, you can set a range of like 0 to, let's say what do we want this one to be? We probably don't want anything over, 29, because this is, or not 29, we don't want anything over like 200. for this acceleration. Let's just copy. And what do we want to do here? We want another float that is our max speed. And we have max speed equal to 100. We don't want that much speed. I measure speed in like the velocity, and velocity measures it in units per units per second, which might be a little bit different depending on what your unit sizes are, but if you have characters that aren't more than 2 units tall or long, much above 16 tends to be pretty fast. So I would range at 16. So we have our acceleration, our max speed. Nothing else we need just yet, but let's go back to our mono behavior. We actually want to replace this inheritance from mono behavior, and we want it to be a scriptable object. So now we're making a scriptable object, and to make a scriptable object, we also need to create an asset menu for us to create this thing. Oops. Create asset menu, and let's get some complete because I don't quite remember what it is. It's something like file name equal, and then quotes because this is a string value, and then I like to delete everything with scriptable object. File name is going to be the direct path, or not direct path, but it's going to be the directory path that it shows you. So we go scriptable object, and I take something like this. And then there's like a comma, and you can get menu name, which is, actually I screwed that up. Menu name is the file path. And file name is just what this file is going to be named inside the asset menu. And then we have order, which is really straightforward. I want it to be top, so 0. And this does not really matter. This is like, unless you have hundreds of these little scriptable object types, you're not going to need to order them specifically in your asset menu. But nevertheless, you can do it, especially if you're making big packages and selling them instead later. You'll probably use order a bit more. So move states, SEO. So this should all be set up. And then in order to use this, what I would like to do is go in and erase remove context. And in here, let's go and make a let's make a new region. So a new region, and this type is going to be a little different. It's going to be of scriptable object references, so I might label that project references maybe. Project references, so anything that's in the project that we're referencing that's not necessarily in the scene or on the object that erase remove context is on, that's what we're going to put here. End region. So if we have end region, then what we're going to want to do is create a protected not scriptable object. We want to do the move state SCO. And that'd probably be our RMS underscore SCO. And we don't want to set it equal to anything. What do we want to do this? This is probably going to be idle. Yeah. Okay, so we're going to want to do that for all our states. And the reason we're doing this and not, and then we'll review why we're not doing it with just putting the fields in here. So we have race remove context, move idle, SCO, and then we have I'm just going to go right down the list on top. Stun, idle, and then we have grind. And then we have drift. And then we have dash. Then we have accelerate. And I didn't want those capital, but and the reason we're doing this is so that it's easier to plug in and add more variables as we go, because this can be passed into one of these, or they can just get access from it, which is what we're going to do. So if we go down to our accessors, yeah, go all the way down to the accessors. And we should put some more regions in. Let's close this one for right now. Change states region, and yeah, there we go. Let's close those up just because we'll be doing it back and forth for a little bit. Let's do some lines, and then access to move state parameters. Move state parameters. So that'll be a public public move state SCO, and then idle underscore SCO, and return idle SCO. Hopefully I can get some autocomplete. Stun, get, yes, yay! Sometimes autocomplete is helpful. Public, move state, not stun. Why'd you do that? Stun being, next one is stun, idle. Oh, can't do capital because this was typed incorrectly. Whoops, that's not correct. Idle SEO. Those are labeled correctly. And there's probably misspellings like idle or something, but idle SEO. Then we go idle the speaker. Okay, I see my problem. Grind SEO. Get and that be return grind SEO. And keep going. What is it? 11:11? Grind SEO, and then grind drift. Yes, writing then rewriting isn't always the most exciting, but saves time other places. Because the last thing we want to do is change something that isn't supposed to be changed, or have our multiplayer network change something that's not supposed to be changed. This type of thing is really important to remember for doing, especially when doing multiplayer, because we need to keep in mind where our client and our server are, and who's supposed to be authenticating an action or an input. Dash underscore SEO. Return dash SEO. And we have one last one, public. Public move state SEO. ELERATE underscore shift SEO and get accelerate SEO. Cool. Now that that's all done, that'll be done when we go to actually hook these up. In the meantime, we'll start with the one, make sure everything works. We'll start with, doesn't really matter, but we'll start with idle, since we default everything to idle and then set that up. So let's go to not race move state, let's go to idle, and let's override. Let's go to our methods, and underneath this, and let's actually open up a new region, because other stuff will go here too. Region, move player, and it's going to be end of a region. And the first one we want to do here is public lowercase override. And this one is going to be move. because that's what we called it before. Needs a type, which is going to be void, so we don't return anything. Public override void. Public override void move. Looking at the move, no suitable method. I think we take in a player move context, don't we? So it's racer move context. Racer move context ARMC. Or is it? Maybe we have to go back. I have to see what it is. Move ARMC. Racer move state. What is move RMC? Does this public void? It's not. Virtual. I want everybody to be able to override move. Go to idle. Okay, so move. Okay. So you could have the state have a value, but that's not very easy to change since this is a normal C# class. You could have this have value, which is easy to edit but wouldn't be very useful because you can't just change it and have it affect all characters. You'd have to go through each one and change it on every prefab. Which brings us to the SCO, which actually is this one, where we store these variables and we can edit them later. I'm just trying to think of how the best thing for movement would be, and it is, so we have a choice here. We could, we'd probably want to overwrite this function every time and just leave it as is. Reason being, even though it takes up like more space, it might not be that big of an impact on most games, and also then we can do a little more with it. So if I go back to my racer move state, and I take this add force here, and I put it in idle, and then I plop it down and move, this would do what I expect it to, and then I can do multiply by the accessor we just made, which is idle. So it's a RMC dot idle dot it's not idle underscore SCO. Type vector 3. Oh, because we haven't finished this line yet. And SCO dot, and then we need the value, which is the acceleration, which I'm just going to go move state SCO and look at it, which is, hey, this shouldn't be capitalized, acceleration. Because even idle is going to have an acceleration. So inaccessible due to protection. So we make an accessor for it. Should make it for both of these because these will both be used in that way. float acceleration. And then we're gonna, oh, no, that's not quite what I wanted. Get return acceleration. I don't want this one. Alright, acceleration. And I want max speed. Public. Max speed. Return max speed. That works. So we're saving. Okay. So now those are accessible in the move state. So we'll go back to idle. Save idle. So now the acceleration. So the normalized direction, which is 1. So it would be 1 force forward, but we need a higher force. So we multiply it by the acceleration force that we want it to be, that's stored in the SCO. And its force mode is force, so that's a constant force and a smoother force. And let's see what this looks like. So the last thing we need to do before we do that test is let's make this a serialized field. Control C. Let me just do this for each one. Okay. We could also make an object to just hold all this information. It doesn't matter for right now. It would be another mono behavior that we have to manage. Manage its mischief. So let's go ahead and pause. Or not pause, but switch. So once that's all saved up, we'll go back to our player bod and we'll look at it and we'll notice these new things are here. Move state SCO. Which is good because that's where we're going to put all of our reference stuff. So let's go to parameters and open the folder. Left click, right click, and let's go to create. And we see scriptable object at the top, and we have move state. So move state SCO. We'll go ahead and throw that. Click on that. Again, it doesn't show the pop-up windows. It only shows my main editor. So apologies for. Well, maybe look at trying to get that a little bit better, but for the moment, it's just stockable ones that I can show you. It's movement state, so move state S. So let's get rid of that default name. Let's call this one idle. Idle underscore idle underscore params. And the wonderful thing about this is you'll see if you select it and go over into the expector, you can adjust the acceleration and the max speed that you want. We haven't done anything with the max speed variable yet, but you can alter the amount of acceleration it receives. So let's go ahead and watch that. It's going to be play. But not yet. We actually have to look at the player bod. So in here, we'll go and select our idle, and we'll select idle params. So now we know if we get a ridiculous behavior as the base if we don't override our method. We have a parameter system that we can go through and edit for certain parameters. So for those move states, you could also add more stuff for camera, or you could have camera information separate. A bunch of things to just handle settings that your designers can just go in here and say, I want it to move faster or slower, or accelerate faster, accelerate less. Yeah, we want acceleration 0 because not all states will have an acceleration. Like idle will just stand there, but for testing reasons we'll leave the 100 just so you can see that it does in fact use that acceleration. So we go through, we do a run, and you'll see it does the same behavior. That means all of our connections are working correctly. And we can go ahead and look at the, and if we change that to 0, hit play, you'll see that, or should see that it in fact doesn't accelerate. So that's that part. Okay. So then what do we want? Max speed? Oh, that was the one thing you could do. You could have variables assigned. You could have variables assigned in here that pull from the different SCOs when they, like on object enable, that take and store that information, which is helpful if you get to the point where you're like referencing too deeply. Like once this gets into, usually my rule of thumb is once there's 4 dots, it's time to change it, because that's just too many. And it could be something as simple as doing an as statement up here. I wonder if that does work. No, it wouldn't be because it's a specific reference. But anyway, you could like save them up here in variables, or like as part of the constructor, I think is how I did it, where you pass in a raceMove context into a constructor that you make, and then that raceMove context can do everything it needs to for setup based on the values in the SCOs that are set up on your player. And show my code for a minute. That can really help out that way. It's more useful when you have a bunch of calls, like when you start doing camera type things. It's not super helpful when you're just starting out in movement type things. But we'll probably see that when we get more towards camera. A lot of easing, if you want to set up that sort of thing, is better to do with parameters and can get kind of long, especially when you start dividing. But for now, this is all working pretty well. It's working perfectly fine. So decision would be to, do we want to connect all these and make sure all the state changes work, or do we want to focus on wheel rotation? It's 11:28, so I think we still have plenty of time to go through and look at the rest of the state machine changing states. So then let's go ahead and do that. First thing I'm going to do before, so we have something to test later, is I'm going to go through and just so we have, I just command duplicated a bunch of those, right click, rename, and I'm going to rename this to be, just go down the line. We got stun, stun, rename it again, underscore param, and we have the param. So stun param, I just wanted to make sure I had all those so that we can link them up and make sure they're ready to go. And it is going to be, next one is, so we have stun, idle, grind, grind param, so let's rename. Yeah, the goal in coding is to make it as reusable as possible so that you don't have to do any more work than you need. Also, it ensures that it being more easily used, ensure that it's more easily uh, more easily referenced, more easily usable. Script object, smooth state SEO. I don't want more of them. I wanted to rename accelerate stun racer. So this one should be drift param. Drift. Then rename. And I want idle. This one. Don't have dash. So we have stun, grind, drift, dash. And last one we should have is accelerate. 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 For anyone that's into punk bands at all, that's a good one to check out. Or a good song. Good song to check out. What do we have? Dash, drift, grind. So these are all here, these are all here, and I want to just throw those in referenced correctly. So stun param, and we go grind param, and we go drift param, accelerate param, dash param. We'll edit these later, just wanted to make sure they're there for when I'm working on it. Because we need to state change something. So idle is 0, accelerate is 1. Accelerate is 1. Accelerate everything's, this should be at like 100 on there. And then, so we'll change from idle to accelerate. So then we should do move context, usually move runs on that. I wanted run something else. We're going to simplify this a little bit. I don't want to complicate the move state or the race move context anymore because it's already getting to be, what is it? It's already like almost 200 lines. Most of that's empty, but still 200 lines is starting to get a little long. At least in terms of game design, we're not doing huge complex calculations, at least in these scripts. And it's best to leave those kind of separated because we don't lose that much memory just for having an object. We lose more having running a bunch of loops at once. more where our memory gets used up. So let's go ahead and create something for input, okay? So that we can input before we change states. I'm going to go ahead and go up to my assets. I'm going to probably go through and create a folder, we'll call this inputs. Call it, the input system has so many named things like player inputs and player inputs. Maybe we'll call this one racer inputs. Racer inputs, and we'll open that up. Then we'll create, right click and go create. And I'm gonna look for the thing that I want is player input. How do I, where is it? This is one of those cases where having too many options right next to each other that you have to read through is a real just pain and bog. Let's see, can we go player body? I can't read it right now, so we add a component. And input, no. It's installed, correct? Just gonna make sure it's installed. Input system 1.7 is installed. Create shader, text, scene, prefab, pipeline, audio mixture, material, render texture, lighting map, custom render texture, animator controller, animation, avatar, single, GUI, skin, custom font. Let's search. Search assets, indexes, or scenes. No. Input action. Whew. Racer input. Okay. Sometimes the worst part about Unity is just finding something in a menu. So let's go ahead and we'll just go player bod. I wonder what will happen if I just drop this on there. Does that add anything? Let's try player. So there's player input manager and player input. Player input manager, I believe, is the multiplayer solution. So you do player input manager if you want inputs coming from a different controller. Like if you have two controllers running for the same game, like when we do the split screen attempt, it'd be input manager. Yeah, I believe. Send messages to game objects. We're going to invoke Unity events. That's the way I learned to use this. I'm not certain what invoke or send messages would be for, because there's send messages, broadcast messages, invoke C# events. That would be if we had C# events that we specifically wanted to invoke. We're using Unity events. They're Just slightly different. Regained event player input. And then default map, none. So we'll take a look at the input. So it's right click, create, and input actions. You won't need a whole ton of these, mostly because these also have extra maps that you can map to, that sort of thing. So control scheme, we're not going to worry about a control scheme. We're just going to do new action map. And this action map's going to be what? Basic drive or something. You can even just name it player or racer input. I'm just going to call it racer. What would it be? Just call it racer key. Or no, that's not right either. Racer, I guess just racer underscore con for controls. Let's just go ahead and delete that action just to be sure. I want, oh, I guess when I add new, that comes up. So there's a couple different things you can do. You can add a control scheme. You can edit control scheme, duplicate. So this one player input action type thing, you can have multiple control schemes. So you could separate your controllers based on control scheme. And then you can also do some other stuff. You'll want to do save asset checkbox right there. Oh, and you can't see the tabs. Actually, I don't do these 3 actions at the same time. Let's do it there. So eraser input actions, I just docked my box so you guys can see it. There's a action map. You can rename this. I just called mine racer con for racer controller. Didn't really want to do a lot with the name. Don't need it right now. Actions. So we have new action and we have key binding. New action as a button. So to set up our movement, we actually need so I'll call this like move v2. So move v2, we don't actually need a button. We need a pass-through value, and we need a type of vector 2. We could do vector 3, not really worth it. And what's our interactions? I'm just going to leave these blank for right now, but you can add interactions that are like when it's hold, when it's multi-tap, when it's press, when it's slow tap, that sort of thing. We're not going to use any of that for right now, but it's probably more useful for mobile. At the same time, for mobile, usually like to use the class directly in code in C# rather than trying to use the input manager. I think this works best for like desktop type games. For PC or console, it probably worked better than mobile, just because mobile input's kind of touchy. It's best to just use the class and get your touch context rather than trying to determine context in here. But it is possible to do in here. At any rate, we want a binding. We want an up, down, left, right composite actually, not a normal binding. So we're going to delete the binding. And if you left click, select, right click, add up, right, left, down, or 4 direction composite, up, down, left, right composite. Then we're going to get a vector 2, and up is just composite path. So composite part is up, so this is for the up part of the vector. we want its, we're doing the keyboard right now. Come on. Binding path process. So binding, why is this not? This isn't working quite right. I should be able to click on this freaking little arrow. There we go. That's just weird. Might be the way it's laid out on my display. Listening for access. W. Okay, here we go. Maybe this will go faster now. Stick down, scroll down, right down. This used to be a little bit more easy to use. There used to be a listen tab that I could just hit and it would be. What's this look like? That's not what I want. I don't like this new one. 2019, I used to be able to just go in here, say, hey, listen to my keyboard, and it would do it. Even in what would it have been? 2020? 2021. S keyboard, here we go. The hitbox is also ridiculous. What happened here, Unity? What happened? So this is an A key. A keyboard. Okay, I see what it's doing now. So it listens on, okay. Listen automatically. Okay, so you click path, then when you type a letter, you get D, and that searches based on the text. So if you write D/keyboard, then it'll search for it, find it. I missed the listen function. I hope it's still somewhere. Processors RacerCon. So WSAD was sad. And we go to our next section, which is going to be, now that we have this, we want to click Save Asset. Make sure to click Save Asset, autosave, or it will not work, or save, or be updated, which is a fun feeling. So we need to go to Player Bod, check out our player input. This is here. And then in events, we can see the events we added. Should be RacerCon device list. Controls changed. It's under RacerCon. So we can move V2, and the list is empty. So let's go ahead, and we don't want to add anything to this quite yet. We want to go and create our script to do that. So we want to go into our move settings. We'll need a new class, because we don't want to do this in racer move context. I'd rather hook it up with something else. I'd rather set up something else for an input, because then we can still reuse all this context information stuff and not have to replace anything in this class or edit it. We can simply put it on like a bridge class for input. And while this input gathers the input, it doesn't do much else. It doesn't filter it. It doesn't call anything by itself. You have to set that up. And I actually think it would be easier to just go ahead and go into scripts, and we look at our eraser movement, move states, and the move context. And just in here, I'm going to create a C# script. And what do I want to call this? We'll call this input manager. We want to stay away from anything that would be a very common name, because Unity might have used it already. So we'll maybe we'll call it like racer input handler. Stay away from handler. That's used more in when we get to other types of coding, specifically delegates. Racer input. Manager doesn't really manage. Maybe we'll just call it bridge, and we'll look for a better name later. DG racer input bridge. It's probably spelled wrong. Anyway, we'll open that up and move over to the other side a bit. I'm gonna do my comments for that one. And then I'll switch you guys over to see it. Alright, so the code, we're gonna get rid of start and update. We're gonna leave that alone. Don't really want that. And then we want are we gonna start with some vars? We'll leave a var spot, but mostly I think we're just gonna work in methods, vars, methods, and in methods, what do we want to do? Methods, we're just going to kind of look at doing some stuff with calling to other methods. So move state SCO. So eraser move context, that's what we want to look at. I'm actually going to move this one to the end because I don't really need it. Input bridge and move context are going to talk directly into each other. So we're going to look at this. So the one thing we need to do is decide where our vector2 is going to be stored and where it's going to be called from. If it's stored in the input bridge, then we have to make sure all the classes have access to that, like all the substates. And if we want to have it in the eraser move context, then we have to have that constantly updated. So right now we have fixed update being called in the move. This is fine. We just need to decide, are we updating it in here or in here? Input might be the easiest one, most logical one, especially since he's getting input. So if he's getting input and handling all of that, maybe it's best to put it in here just so we know where it is, and then drill down to it using just accessing it through the other objects. So let's go ahead and create a var. Now that we know what we're doing, we're going to go public protected. So we'll go protected. And this is going to be a vector 3. And this will actually help out with the camera a lot too, because then we can just throw the camera class and we don't have to do a spider web that I ended up with on my last practice for a controller. So vector 3 is going to be, that's moveder, stands for, so mov, D, move direction. We can set it to vector 3.0, that's a good starting place. And then we go down to the methods. This is going to be a little bit different. This has to be public because a different class has to use it, even though technically we're getting the input. If you use the old input system, you could do some of this protected, but being that the other input system is calling and using that, we're not going to make that here. We're going to do that. Let the input action script handle it. We're going to need a public. We're not going to need a vector 3. We're going to need a void return type because we don't really need to return anything just yet. And we're going to go, I'm actually going to call something else. What I want to call this method. It's going to be move input, maybe. Just call it, yeah, just call it. Move input, and it's that, and it's got that. I might change this when it comes to certain racer input bridge. So I might change this based on player and based on NPC, and I might split this up into different classes. So I want to keep virtual on a lot of these things and just copy paste them as I go. If we need more classes or if we don't, but for development and testing, we're just going to use this one class and use it as a player. Because again, I want to reuse as much of my movement code as I possibly can, especially to make sure that it's fair for the player to race against these NPCs. It'd be easier to make sure it's fair if they're not just finding the fastest route with nav mesh, unless I have to do that, but that's fine as well. I just want to make sure I'm doing the right process here. Virtual move input. So we want our input to take in a call. Might need to add a using statement. So the domain that we need to be using is just, or namespace we need to be using is unity dot, I think it's input. Might be Unity Engine. Input is not a namespace. Alright, we'll try typing in this call. Input So Alt Enter. Generate class or new type. No, this is alright, I'm just gonna Google that one real quick. I have no idea what the possible frickin' callback is. Callback context. Okay. So it's input action. Okay, I see. I see. It is an input action. This word is together. Callback context. There we go. So using Unity Engine.input system. Callback context. Callback context. Then we'll just call it context. Okay. The reason this looks a little dumb is this is how it's going to call a Unity input event. And it's going to pass this in. So this will only be callable by an input action. And you can generate your own input actions. I just wanted to use this one because it would be a little bit faster, especially for new people than generating a bunch of actions, which takes time. And input action.call that context as context. So we actually get that we can just go read value, I believe. So we can set our move MOV move direction dot y. Then that would be equal to, we don't want y actually. We're only going to do x and z. So we're going to call move. Alright, let's create a new variable just to hold it, because I don't know what I'm doing with this yet. Vector 3. So vector 3 is a move direction. So this is going to be new mobdir, and a new mobdir is going to be equal to context dot read value, and it's a read value of a vector 3 type. So can think of this as our input action sends in an event, and that event has a context. All contexts have a value. In this case, we set the value to vector 3 in our input action in Unity, so we can see that. And since we can see that, now this is getting read into our variable that is a new move direction. So we're just using this as a buffer value so that we know where it is. Because we're going to have to do some processing to convert this vector to, nope, not 3. I messed that up. Convert this vector 2 into a move direction, which is a vector 3. So move direction.x is equal to new move direction x, and this is the y then, right? But our y actually coordinates to the z. So you can think about it, if you look down at it, the conversion would be z is forward on the z-axis, and x is left and right by default. So then our x lines up correctly, because if you look down at it like a graph, it's z up and x cross. So then y would be turned into your z, and x would be turned in, and x would remain your x. So then I'm just going to comment here. Convert y to z 3D movement. And for the most part, I don't actually ever adjust a move direction's y value. That's usually done in a separate script, just because I'm like, I don't really want. There's a very rare place in where you want the character to move by itself in an upward direction. It's usually to compensate for ground values and everything else, but that could very much be done in a different script. It just depends where you kind of want to put your things. So this should all be saved, this should all be working, and then the other reason this bod is a rigid body like that, okay, rigid body isn't going to move, and when we rotate the character, the rigid body won't rotate. And we're kind of banking on that to remain our x, y, z directions, because we get our direction from our transform. So let's go, and then what do we want to do? We got move input, and this is read in here. So this changes the input here, and then this is here. And what we would actually want to do here in erase remove context is we just want and you can kind of see where all those regions are coming in handy. I don't have everything up on screen that I don't want to look at, and everything's really, even though it's almost 200 lines, it's much more readable using this type of development IDE. So what do we want to call this one? This one's going to be just our movement stuff, which we actually have movement variables up here. If we wanted to put them up here, which would be a better idea. Let's go ahead and put this under, we'll just give it a line. And then I want it to be a racer input bridge. Racer input bridge. That is, I think I'll just do RIB, so it'll be a rib. and then we'll do no assignment so that we can get it later because we want to make sure that it's real. And we'll also make this protected. Protected rib, so protect your ribs. Protect your ribs, everyone. We're gonna need another one. I think right under here is where we'll put it. So public eraser input bridge capital rib. It's an important rib. Then we do got, get, and return rib. Something is out. Oh crap. Alright, just delete this part and redo it. That's bad too. Come on. This is one of those cases where autocomplete is bad. Or at least requires too much thought. So return, and we want the little rib. So we got big rib, little rib, and that's all saved up. So now this exists here. And we go down to our move state that we want to use this in, which is idle because we're testing. Then instead of transform.forward, we want to use the ARMC with a capital rib dot we don't want to move input. Do we not? We need an accessor. So we need an accessor of type vector3, public vector3. Movedir get return movedir. I think I need one more bracket. Yes. Then back to idle. Movedir. Okay. So then we're using the move direction that's in the object rather than just the simple forward. So it should be 0, which means the force by the acceleration should be 0. And that should reflect movement. So we go play. Let's go try that out. I need to go back to the params and just make sure my idle param has some acceleration. And I didn't set anything up, so we'll see nothing happen here. it fails because we need to go back to the player body, and we need to add a player eraser input bridge. We need to, maybe we weren't done with that yet. Need to, in the eraser remove context, get rib. Okay, we're gonna make sure the connection works, and then we're probably gonna stop for today. Mouth's just getting dry and getting kind of hard to keep talking and code, so we're gonna probably call it as soon as I get this this test to run. So we have the fixed update move, which calls that move. We have the player body with those parameters, player input. We just need in the context to go to our onEnable method, and we need to get the component that is going to be on it, which is the eraser move. So we need little rib is equal to the get component of type being the it's not the move state SCO. What's it? Eraser input bridge. Eraser input bridge. So this will complete that onEnable, and then that'll allow everybody to use the references of it. So once that compiles, we'll try it again. And it looks like my camera's locked until I complete the domain. Okay, come on, Unity. Okay. Now Windows. Yep. Okay, so now we'll try running. Okay. Now at least we know the reference is referencing. So let's go into our player input. So we go to player container, player body. Eraser bridge, nothing in there. Input, we go to events under erasercon, which is the controller script we made, or controller actions we made. We need to pull our input bridge into there. So select eraser bridge here in our new callback context, and then we need eraser input bridge. We need move input because that's the one that takes in the 2. So this should change all of the information, and we should be able to access that. So let's give it a play. And yep, whoa. So it's really fast, kind of slippery, because the force is going just directly into it. And our plane's kind of small anyway. But you can see the input's connected now. So as we keep going, we'll just keep adding more and more to this, as well as adding to our input bridge. And then eventually our input bridge will also give input to our camera and all those other things, and control all of our input so that we can change how the bridge works in multiplayer and do some easier to it'll make things easier to change how the input works rather than changing how the states and the movement works all together. So with that, I think we're going to leave here, and I'll see anyone who drops in next time. There'll be a quick recap of what happened, or of where we're at the beginning, like usual, and I'll see you then. And then we pull up on the thing, maybe. It's not working.